ECM motors have been in HVAC equipment since the early 1980s. The ECM motor history began with the 2.0 motor and has progressed to the 2.3, 2.5, and to the current 3.0 and other current models that are available. The 2.3, 2.5 motor had a 5-pin high voltage connection with a 16-pin communication connection. The ECM 3.0 still has the 5-pin connection for high voltage, but now has a 4-pin communication module. General Electric and Gentech are the leading manufacturers of the ECM motor line. You can find a lot of information at www.thedealertoolbelt.com. Here, Gentech puts a lot of the information and troubleshooting guides for their ECM motors. Make sure to visit this site and avail yourself of the information that's available there. The ECM motor consists of the main motor body and then the electronic module that attaches to the end of the motor. This controls the torque, RPM, and CFM that the motor is being commanded to run at. The ECM motor is a pretty bulletproof motor. The electronic module is sealed so it's not susceptible to moisture that may get on the motor. And the main component of the ECM motor is the permanent magnet rotor, which is a pretty heavy, durable rotor. And we've had very few motor failures on these ECMs. As we have said, the ECM motor consists of the main motor module and then the control module that attaches to it. If the motor checks out fine, the module can be replaced by itself, so you don't have to replace the entire motor. On most ECM motors, running data is stored in the electronics on the motor. The control board communicates what mode the system is in, and the motor decides what CFM is needed for that mode. One of the calls that we get a lot is from a technician who says, I have high voltage to my ECM motor, but it won't run. And our response is, what about your communication lines? The motor needs to be communicated to by the control board to tell it what it's supposed to do. Once you have verified that you have high voltage to the ECM motor, you next need to check the communication plug to make sure that you have communication from the control board to the motor. Without this communication, the motor does not know what it's supposed to do. In preparing to check the communication wires, you need to make sure that instead of having the large fat probes on your meter, you need the skinny ones that'll be able to get into the plug easily and make readings without damaging the plugs and the contacts. With the larger probes, it is easy to damage the plugs and the contacts, and sometimes it's hard to get the fat probe into the plug to make a connection to make a reading. This is why the skinny test probes are a lot more useful in getting into the plug and not making damage to the plug or the contacts. You also want to make sure that your meter is a true RMS meter. You'll notice from this chart that an average responding meter can be as high as 10% or as low as 40% when reading these voltages on ECM motors. A true RMS meter will be correct in all readings on ECM motors. There are a couple of different ways that ECM motors communicate. The first one is one-way communication, where the control board tells the motor whether it's in heating or cooling mode, and the electronics in the end of the motor decide where it needs to run for each mode of operation. This is a wiring schematic from one of the major manufacturers of a single communication line to the ECM motor. Most manufacturers will have troubleshooting guides that will give the voltage value that you should see on these wires. In this case, between the yellow and brown wire in the off cycle, you will see 0 voltage DC, And when the motor is commanded to run at high speed, you will see 15 volts DC. Another type of communication between the board and the ECM motor is two-way communication. The board communicates to the motor that it wants it to run, and then the motor communicates back to the board that it's running and running data. Here we see a wiring schematic for the two-way communication. The IDM, or the inducer motor, is also an ECM motor, and it has a PW line, the brown and yellow wires, which in the off cycle you will read 1 to 4.0 volts DC, and when the inducer is running at medium, you will see 7 to 10 volts DC. It also has an RPM feedback line, which communicates back to the board the RPM of the inducer motor. This is the orange and brown wire in this case. And in the off cycle, you'll see 11.5 to 12.5 volts DC. And when it's running at medium speed, you will see 9.5 to 10.5 volts DC. We also see the same thing for the blower motor, the BLWM, where the supply voltage on the red and green wire will be 12 volts DC constant. The input on the green and yellow will be 5 volts DC constant. And the output back to the board will be the blue and yellow wires and will be a pulsing DC voltage from 0 to 1 volt DC. Many manufacturers will have a troubleshooting guide for their ECM motors. In this case, a status code of 41 will tell you that the blower motor has faulted, and you will need to follow the troubleshooting procedure to find out what the problem is. This again is out of the troubleshooting guide to follow for an ECM motor that is faulted out. They will ask you, of course, if you have your 115 or high voltage to the electronics. And then they will go through checking the various wires on the communication plug to make sure that you have the correct DC voltage communicating to the motor. Some manufacturers will have flow charts doing the same thing, the fault code 41 blower motor fault, and then they will walk you through the various wires and what DC voltage you should see as far as communication control. The third type of communication to the motor is just a 24 volt input to the motor. The board sends a signal of 24 volts to the motor, and the CFM and torque and RPM data is stored in the electronics of the motor. So depending on what tap you're energizing, the motor will know where it needs to run for that mode of operation. This is a typical wiring diagram of a multi-tap ECM motor. It looks a lot like the old PSC motors that had taps where you could change the speeds. In this particular case, you have red, which is your low heat speed. Orange is a spare that you could swap to change the speed for low heat. Blue is your heat mode. Yellow is a spare that you could change. Gray is for cooling. And green is your 24 volt common. In your ECM motor troubleshooting, one thing you don't want to overlook is the wiring harness. Most often the wiring harness is the problem that causes an ECM motor not to run. Because of shoving fat probes into the wires and damaging the contacts, many times the signal coming from the board to the motor does not get there. And the problem is the wiring harness. So please make the wiring harness part of your checklist to check and see if the signal from the board is making it to the motor and the signal from the motor back to the board is making it to the board.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.